Hi everyone, this is Lakshmi Soumya Udgala. Today I'll be presenting on the topic finding the closest pair of points in a plane. Considering we have n points in a plane, P1, P2, n, and if we are finding the pair of points that are close to each other and we are writing index, we are specifically considering input values from 10k to 100k with an increment of 10k. We have many applications with this algorithm. Coming to the computational geometry, closest pair of point methods are essential in computational geometry for a variety of purposes, including computer graphics, geographical information systems, and robotics. Geographical information systems, finding the nearest pair of sites on a map can aid in route optimization and spatial connection identification. Robotics, determining the nearest pair of locations can help robots avoid obstacles and plan their paths across physical systems. I have implemented the algorithms and conducted analysis on two algorithms that includes brute force approach and divide and conquer approach. For the brute force strategy entails iterating through all the possible pair of points, determining the distance between them. Then it selects the pair with minimum distance by comparing with all other distance. It iterates to each pair of points in the plane, calculate the distance between each pair using the distance formula, that is Euclidean distance, and then it keeps tracking the minimum distance found so far considering the pair of points, and then we return the incident indices. It takes big of n squared time complexity and big of 1 space complexity. For the divide and conquer approach, we usually for finding the closest pair of points in a plane, the divide and conquer approach is more efficient than the brute force approach, especially for large set of inputs. We divide the set of points into two equal halves along the x coordinate and recursively find the closest pair of points in each half. This step involves, if the number of points in a subset is small, for example less than 3, then we use a brute force approach to find the closest pair. Otherwise, we recursively call the closest pair in each function. We also create a strip of points within a distance d from the middle line, and up until 7 points we calculate the minimum distance so that we are not missing out on the points that are dividing the line. For this algorithm, it takes big of n log n time complexity, and space complexity is big of 1. This is the implementation of brute force approach. These are the iterations for the brute force approach. The closest pair of points would be 440.03593 and 440.036. The indices are 31947981 and the distance is 0.84. I have calculated for 10 iterations for the brute force approach. Coming to the divide and conquer approach, this is the implementation. As I said, we are considering the strip, dividing the midpoints into left and half, right, and then finding the minimum distance. If the number of points are less than 3, as here, we are calculating the brute force again. These are the iterations for the divide and conquer approach. It takes the less time compared to brute force approach. Table for brute force approach is this. It includes number of inputs, theoretical complexity, empirical runtime, and ratio and predictor runtime. The graph represents empirical and predictor runtime for algorithm 1, that is brute force approach, where X takes number of inputs and Y has runtime in milliseconds. This is the table 2 for divide and conquer approach, and this is a graph for divide and conquer approach for empirical and predictor, where N takes inputs and Y takes runtime. This is the combined graph for both brute force and divide and conquer algorithm. X-axis has number of inputs and Y-axis has runtime. The divide and conquer conclusion. The divide and conquer technique is more efficient than linear approach by breaking down the problem into subproblems, more manageable subproblems. It sorts the points and dividing them into left and right subsets based on their coordinates. It is scalable and efficient for large data sets with a runtime complexity of n log n, whereas the brute force runtime complexity is big of n square. But in terms of space complexity, divide and conquer takes more space. Thank you.